Good morning, everybody. I can't see my slides. Thank you. Thanks a lot for being here this morning. So yes, I'm Charlie. I'm dev Charlie on Twitter. I am French, but I'm not going to do it in French because I don't speak French very well anymore, so that would be pretty bad. So hopefully it will still make sense with my kind of broken English sometimes. So what we're going to talk about today is mind control in JavaScript. But to get started, if ever I'm speaking too fast or if there's something that you can't see, the slides are already up online, but otherwise, don't worry about it. I'll share them on Twitter later, in case you don't know yet if you're going to be interested. So yes. So let's start by talking about biosensing. So if that word doesn't really make sense to you, it is basically the use of sensors to track the activity of physiological functions. And these sensors can be a lot of different types. So you can buy heart sensors or fingerprint sensors, even alcohol sensors or muscle sensors and things like that. And all of these little sensors, you can actually program for them in a few different languages. So these are kind of sensors where you build your own devices, but there's devices that you can buy online that are already kind of pre-made. And the one I'm going to focus on today is a brain sensor. And the one especially is the emotive epoch that has 14 different channels placed around the head. But before talking about how this device works, we should probably take a step back and explain a little bit how the brain works. So I'm not a neuroscientist, so I'm going to try and explain it in a very simple way, especially because I don't know you to know in depth how it works for the rest of this talk. So we're just going to cover a really basic thing so that you can understand what's happening later. So it starts with the brain. And the brain is made of billions of neurons, and what these neurons are, they're specialized cells that process information. But they're not put randomly around the head. You have millions of them, but they're organized in different parts. And different parts are kind of they're here to kind of deal with different things, different functions. And for example, the parts in green are the parts that are involved in dealing with movements. So you have the primary motor cortex at the top and the cerebellum at the bottom. I apologize for this very image. I had to draw polygons myself. So yeah. So these parts of the brain, the cells actually send their axons down the spinal cord, and then they're kind of connected to motor neurons that activate muscles. So basically what's happening is that your entire body is connected, and neurons send electrical signals all over it. And as we're talking about motor functions, I thought I would show you that you might have seen before. That's called the Cortical Homunculus. And what it is, it's a distorted representation of the human body that is supposed to represent how important certain parts of your body are for your brain. So how big certain parts of your brain are in kind of in processing motor functions. So as you can see, for example, the hands and the face are quite important in the way the brain thinks about the parts of the other body. So this is going to be important for a bit later during the talk. But when we talk about tracking the activity of the brain, we usually talk about brain waves. So as neurons send electrical signals, they end up creating electromagnetic waves, and so you call them brain waves. And there's 5 main brain waves that operate on different frequencies, and they are responsible for different things. So for example, if you wanted to build an app that deals with meditation, you will probably focus on the theta waves, the second one. But if you wanted to create an app that would help users be more focused, you would probably focus on tracking the gamma waves, or the beta waves, actually, not the gamma, the beta, that are more about concentration and excitement. So all of this is cool, but now how does the brain sensor work? So the brain sensor actually has a lot of different electrodes around the head. And what you see here is the 1020 International EEG system that kind of shows you where certain electrodes should be placed around the head depending on what you want to track. So I don't know if you see properly, but each node has letters and numbers. For example, FP1 and FP2 are the ones that are supposed to be above the eyes to track the state of the eyes. And the ones in green and orange are actually the ones that the emotive epoch has. So it shows you a little bit that they tried to cover like, let's say, like different parts of the head, but of course you have 14 different sensors, not like hundreds, so it doesn't track as well, but they try to still cover different parts of the brain. So this is cool, but what is really important is that as developers, you can actually program for these kind of devices. And what I've been working on is to create a Node.js module that JavaScript developers could, I mean, actually any developer who wants to write JavaScript can use to interact with the brain sensor in this language. So they do have an SDK in C++ and Java, and I think now they have a few more, they've developed a few more, but at the time when I bought it, that was it. So I worked on making it available in JavaScript so more developers could use it. So what does it do? When you don't have to buy the sensor to write a program for it, so you can download what is called the Emo Composer Emulator. And as sometimes it takes a bit of time to set it up, and sometimes it's quite fragile. You might not want to kind of like walk around and carry it everywhere. So you can launch the composer, and it's gonna emulate that the brain sensor is on, and you can send actions to your program to see if you're receiving events properly. But you also have access to live data. And when I say live data, I'm not talking about raw data, but you get some events, but I'll talk about that a bit later. So you have access to the hardware. So the sensor has like a gyroscope and accelerometer. So when you move it around, you can have the X and Y kind of like data of it. You have access to performance metrics. So you have access to the level of focus and excitement if you want to build apps with that. You have access to facial expressions. So there's like a predefined list of it, but you can track if you're smiling, if you're blinking, winking, or looking right, looking left, etc. And you also have access to some mental commands. Again, there is a predefined list of maybe 10 commands that you can train. And some of them are pushing, pulling, the direction right, the direction left. And all of these are now available in JavaScript. So the tech stack behind it, I had to use the C++ SDK. That was a challenge, but so yeah, that's like the background. And yeah, so I built a Node.js module on top of it using Node.gip, Node bindings, and nan to make it all available in JavaScript later. Oh my god, already. Okay. So live demos. I always kind of wonder, why do I do that to myself? But, OK. So before we start, before I do them, I like to remind people that it doesn't always work. It worked this morning. I tried it. I tried all my demos. There's 3 of them. So they worked. But this is like a different, it's not my hotel room. There's like people and stuff. So it's a bit different. But hopefully it will still be OK. So the first demo that I built, and I'm going to try and speak and set it up at the same time. The first demo that I built was a brain keyboard, and I wanted to just test the tracking of the facial expression. So I basically have like a really simple keyboard interface in the browser, and I'm able to select letters and write messages using the looking right event, looking left, and blinking selects the letter and displays it. So as you can see, while I'm setting it up, you actually have to put some gel on all of the sensors before getting started, so it conducts properly. So I'm actually putting everywhere. I should have brought a napkin. But so it can take a bit of time. That's why sometimes if you build a program, you actually just want to use the emulator, so you don't have to do that. Also, I know that the more gel I put, the better it's going to work. This morning, it worked like really well. I was even impressed. So. OK, so so I have to plug that, and this is where I don't know if it's going to work. So, because I already have something plugged in. OK. So, is that going to work? OK, that seems to work. So I need to put it on. OK, so, yeah. I can't, OK, I'll try and see myself in my screen. OK. OK, so now I'm going to turn it on. Gel everywhere. I'm just checking the USB. I should have a light. And it's not turning on. I'm just going to try. So there's a control panel where you can check if the live sensor is actually connected properly. OK, I'm going to have to unplug my clicker. I think that's the thing. I'm going to turn it off. I'm going to turn that off. I don't know if you have one of the new Macs, but if you buy a dongle to try and have USBs, you can't plug two at the same time. This is great. Wait. Seriously, that cost me $150, so. All right, so. Oh, come on. Okay, one, and then give me the other one. Give me the other one. It's not giving me. Okay, try that. I brought all my dongles with me. Okay. Yes, okay, so this one works. Let me just, I want the control panel. Let me just check the state of the sensors. Oh, whoa. Okay, so green means it's really good, and red means I might be missing a thing. But that's fine. It's red all over the head. It's green all over the head, which is really good. Okay, so let me just check. And then, so I have to go on 3000. So I have my thing. Okay, so I blinked, so it wrote H, and then I look right, and I blink. Oh, yes. And I go right, and I blink. Come on. Oh, no. Okay, wait. Yes. On the right. Hey. Oh, are you working this morning? No, okay. Yes. Woo, okay, I'm going to stop here. I'm not going to move. Ah! Okay. I'm going to do it with the keyboard then. So that was the first demo, and that used the signals that you get from different brainwaves depending on the state of your eyes. But then the second one that I worked on was, forgive me for the terrible UI, but I wanted to try and navigate a 3D space using the thoughts. So not the eyes, just being able to focus about the thought of like, I think it was direction, so left, right, and there's maybe I think there's a pushing or pulling, so or like forward or backwards. So that is quite unreliable when I do a live demo because I'm not in a normal state, but I'm going to try anyway. So, and I'm going to, okay, there's this thing here. Okay. Escape. Okay, and if I do, okay. Oh, and woo, and now wait. I'm struggling here. And you don't even know what I want to do, so that's cool. I'm gonna close it, and I'm gonna try to explain to you what I'm trying to do. So what I want to do here is I'm trying to think left and then right. So the right worked, but left, it didn't want to go back left later, because it's hard to focus when I know that there's people here. So either right or left should work. So if I do like, come on. Oh, yeah, okay, not the other side. Go to the other side. Oh, okay, kind of. It's left, but like, yeah. All right, so I'm going to stop here before okay, and the last demo that I wanted to show is that, as it's JavaScript, it can also run on hardware. So you can build interfaces, but you can also do stuff with like drones. It's useless, but I don't know why people like drones. So I'm just like, I just bring a drone. Okay, so for this one, so the drone connects via Bluetooth. So I need to turn on my Bluetooth. I'm going to put it there's a lot of space, so that's cool. And what I'm expecting, so I'm not using the thoughts for this one because it's a bit hard when you're on stage, but I'm going to use the facial expression. So I should look left, and it's going to take off. It should go a bit forward, and then it's going to land. It shouldn't go very far. Shouldn't go very far. Okay, so I need to wait for it to tell me that it should connect first. Okay, it's connected. So if I look left, left. Okay. Yes. Oh, it didn't go very far, but okay. So I'm going to try again. I'm going to do something, but it's terrible code. So Where is it? No, this is not that I want to do. This, I'm going to put it 20. Okay, so tell me that you're connected. Connected, and then I look left, okay. Oh, hello? No? Is it on? Wait, left? Yes. Oh. Woo, it's going further. Okay. And I'm going to stop because I don't want it to go back in. All right. So we are done with the demo, and I have gel all over my hair. So next. So code sample very quickly. I really want to basically show people that it doesn't have to be hard to play with hardware and brain sensors. Like when you start with it, you think, like, oh my god, I need to know so much about the brain, but actually you don't have to at first. You can learn along the way. So in the, it's a Node.js module, so you start with like a server file. So you basically just require the module. Then you call, the functions that are built are connect to live data, where you give the path to the file that you make when you actually train your brainwaves through their software. But you also have connect to Emo Composer function, so that if you want to just test stuff in JavaScript, you don't have to connect to the live data. So yeah, as I said, when you, Emotive has software that you can download where you train the mental commands. So you don't have to train anything for the facial expressions, but you have to train things for the mental commands, and that saves a file in your computer, and you just use that file. And then you have a callback with an event object. And yeah, so that's not great code, but that's also something I do on my own time, so I don't always have the time to refactor it. But it's basically, it comes back with an integer 0 or 1 if, with the state of the facial expression. So if you're looking right, if it's more like, I could have said if it's 1, but I didn't. And then you just set an action, and you just send the action via WebSocket to the front end. That's if you want to do front end. So that's part of the very kind of small code sample for the keyboard. If you want to stay with the drone, you don't have to send anything using WebSockets to the front end. So as you can see, it's not all the code, but it's like a little part of it. And in the front end, it's basically you create another like WebSocket connection, and on message, from the messages that you got back from the Node.js server, you basically have, if you blink, then display a letter, or if you look right, then do something else. So there's a bit more than that, but it's like I try to make it very simple. So you just require, you kind of just look for events coming back, and then you do something with it. And it's like really up to you then to decide what you want to do with it. So there are some limits. So first of all, yes, you need training for each user. That's a bit normal. I know that some people don't really believe in that technology because they're like, oh, people have to train it. But I mean, of course, like if it was the same for everybody, then it would mean that we think the exact same way, which would be a bit sad. For the facial expression, not really, because, for example, you have brainwaves that have spikes when you close your eyes, and that they know, like it's not really tied to a certain thought, like the beach or a beer or something. It's just spikes in brainwaves when you have some facial expressions. You can't track everything. As I said before, the Emotive doesn't allow you to have access to raw data. I mean, you can if you buy the license, but that's a bit expensive. If you don't use it every day, I don't know if it's really useful for everybody. So you only kind of have access to the events that they let you use. There are other brain sensors that allow you to have access to raw data, and I'll talk about that a bit later. And when I say you can't track everything, it's of course also the fact that we don't really understand how the brain works yet. So we can't really extract the thought about, oh, I'm thinking about a bottle of water. That's way too abstract, at least at the moment, to be able to extract that kind of thoughts. But it doesn't mean that we can't do something with what's already there. Latency, I think that has more to do with probably the machine learning algorithm that they have that they're using. That's kind of like they don't let you know what kind of machine learning algorithm they're using. You just know that they record your data, and then they probably run something in the background. And it's probably, I mean, I don't know if you know a little bit about machine learning, but like you probably need to know what, like the data that you had a few seconds before just to, like it's not just the data that you get right now. You also have to get the data probably a few milliseconds before. So it's like there is a latency because it will have to recognize, is the person still thinking right, or is it now switched to left? So for example, if you want to build like a self-driving, like a mind-controlled car, I might not want to do that yet because, well, you know, you have to be quite responsive. And another limit is the temporal versus spatial resolution. So when you have an EEG brain sensor, like this one, The temporal resolution is pretty good because the data comes quite fast, but spatially, it's not great because 14 sensors can't actually track everything that's going on in the brain, but you have other ways to track brainwaves like fMRI, which like the spatial resolution is great because you see the entire brain when you scan, but temporally it's not great because the scans don't come back as often as you would like to. So at the moment, there's no method that allows you to do that have like a temporal and spatial resolution that's really good, but it doesn't mean that it might be coming. So there are some limits, but there's also opportunities. Accessibility, that's the one I can think of. Of course, well, I mean, the prototype of the keyboard that I built, it's still very much a prototype, but I mean, if I was spending a bit more time, maybe it could be a bit more accurate. But what I mean is it could really, like, maybe you don't need it because you can type on a keyboard, but it doesn't mean that not everybody could actually benefit from things like that. And of course, I know that sometimes you might not want to wear it because it's quite big, but it could really help some people. And I know that some people have actually been working on being able to control a wheelchair with your thoughts if you really can't move any part of your body. So there is still some applications, even if it's not maybe 100% accurate. Like, it's still amazing that you can buy that online. Now. So if you have a family member who can't move or anything, they can still communicate with a really prototype that I built, you know, or that you can build. It's not about me, it's just about proving an idea. Of course, mental health. I know that some other brain sensors are actually more focused on that because it's, as it is relying on some brainwaves that we know are about meditation. They are building applications to help you relax, and you have that feedback straight away. So if you want to start meditation, sometimes it's really hard to know if you do it well, if you're doing it well. But if you have that feedback straight away, you can train yourself to be better. And finally, art. And I'm talking about this one because a lot of the times when I get interested into a new technology, I use just creative random ideas to play with it because, like, I don't have boundaries, or I don't have a client requirement that tells me, no, you can't do this, you only have to do like forms for your entire life. I'm working on a form now, that's why I'm saying this. And I really try to use art and technology as a way to explore things I wouldn't have access to otherwise. So there's a thing that I'm really trying to convince people about, is that useless is not worthless. Like, there's a lot of things that I wouldn't have learned if I didn't try to build something stupid with it. At first, when I bought the brain sensor, I didn't think about a keyboard that you could control with your eyes. I was just thinking, oh, it would be cool if I could listen to my favorite song and see my brainwaves. Like, it's a bit like, now that I think about it, I'm like, oh, no, I don't want to do that anymore. But as I started playing with that, I realized, well, actually, it could be, like, I could turn that into more useful ideas. But the knowledge that you gain from playing with that stuff is definitely not worthless. So what's next? So I recently bought this brain sensor that's called an OpenBCI. I think I bought the one with 16 different channels. And this one is open source. So this one gives you the raw data. And it's good and bad because it means that you have to learn how to do the data processing and understand what's happening. But it means, like, as it's open, you can really do whatever you want with it. So I just tested it very quickly last weekend because I didn't really have the time. So I just set it up and I tested it. As you can see, it's even bigger than that one. So I'll definitely not go out without my face. But it's what I was trying to show here. I was just testing that when you close your eyes, you have certain types of waves that have a spike. So I was just testing, is it connected properly or not? So you have feedback of, so on the left, there's only 8 of the sensors, but I didn't want to turn on the 16 ones because you probably wouldn't be able to see. But yes, on the right, you have like a live plot, and you have the access to the accelerometer as well, so you can still play with movement. But that is really cool because what I would like to do, what I would like to get to, is to work on this. So this is called deep image reconstruction. And what it does is that you kind of record brainwaves of somebody watching a video footage on the left. And on the right, you have the reconstruction of this video using your brainwaves. So as you can see, it's not super accurate, but it's still pretty amazing. And I don't really know what we're going to do with it, but if you were thinking about what if you could visualize your dreams when you wake up, and, like, I don't know, maybe it would be useful for, I don't know, therapy, I don't know. So, I mean, I don't really know what it would be used for now, but I still, like, I find that really amazing that it's possible, because what they did is, like, so it's tracked when you're watching that video, and as you're still watching it, somebody else could be able to see the image. But what they're trying to do as well is to recreate that image without you watching the video. So you watched it once, and then you don't watch it again, you think about it, and you would try to recreate that as well. So you could, instead of just selecting letters on a keyboard with your eyes, you could literally train yourself to think about the letter A and having it written. So we're not there yet. They have tried to do that with letters, and it's still, like, it's pretty okay. But you have to still be watching the video and transmit the brainwaves. So we're not there at the point where you can just think about the letter. But it means, like, they just started doing that. So with the advancements in sensors and machine learning, that would be pretty amazing if we could get to that. Another really, really interesting thing, so as I showed you the cortical homunculus at the beginning, this is, like, amazing. So this doesn't use a brain sensor, because what happens is that when you put the sensor on the brain, you have to filter a lot of different brainwaves. And it's not only about your movements, you have a lot of things happening. And as we saw before, that the representation, like the importance of the hands in the parts of the brain that are activated are quite important, you can actually track brainwaves that go all the way to, that you can track the motor neurons that activate the muscle, so that it's already all filtered from all the other stuff that's happening in your head. You can get the filtered electrical signals that are just supposed to be activating your arms, and you can train, and you can then, so what's happening in this thing is that they've trained the algorithm and the sensor to recognize movement without having to move. So here, the person is actually thinking about doing that movement, but they're not moving. And that's pretty amazing. And it means that really you could just train it, and you could really, like, in terms of accessibility, it would be really awesome. I think they're more focusing on improving interaction with devices. I think the founder wants to be able to provide a better experience of interacting with your mobile device without having to type. That's not the first application I would think of, but that's what they're focusing on. So as you can see, they're just, like, typing on not a keyboard, but it knows exactly where the movements are. So that's really, really impressive. And what I want to show next is that, of course, they're working on it every day. And they're like a team of researchers, but it doesn't mean that anybody in this room can't try to do the same. So I'm going to show something that I created very recently that doesn't do something great, but basically I have what we call a Mayo armband that tracks exactly that. So I think the armband is more tracking the muscle movements rather than the actual neuro-like activity. I don't know if there's a difference, actually. I should check. But what I was trying to do is I trained two different... so when you buy that sensor, you have access to predefined gestures as well. So you, like, wave right and wave left, and you can control interfaces or devices with that. But they give you access to raw data as well. So then you can record it, and you can play a little bit with machine learning, and you can create your own custom gestures, or at least that's what I'm trying to do. So I just trained two very basic ones, so either neutral, I'm doing nothing, or just, yeah. So, and that's a very, like, early prototype. I haven't showed it to anybody because, I mean, only to one person, because it's, like, it's not there yet, as you can see, but I didn't train it with that many samples of data. So, of course, it can get a bit better. I think I recorded the gesture maybe, I don't know, maybe 40 times, 50 times. So that's not, like, in terms of data set, that's really small. And also I used K nearest neighbor algorithm, and I'm not sure that's the right one. So I'm just experimenting with that. And of course, like, the goal is not to have that gesture, but it would mean that anybody could, instead of having to learn to do the gesture, you could actually make your own. And then you write the interaction. So that's pretty cool. Getting started. So if you are interested in playing with brain sensors, you don't have to buy these ones because they're a bit expensive, but you can start with other ones that are a lot cheaper. The first one I started with was the NeuroSky on the bottom left. That's a lot cheaper, but there's only, like, I think 3 sensors around the head, so it's not that accurate, but if you just want to get started and see if you want to keep going, then that's pretty cool. One of the famous one is the Muse, which is the second one, and I think they focus a lot on meditation and focus and things like that. And that's a pretty cheap one as well. And some people even wrote stuff in web Bluetooth, so you don't have to care about a server. I just put some resources. There's quite a few modules available for the OpenBCI and the Emotive. I mean, like, for the Emotive, I think there's only mine in JavaScript, but for the OpenBCI, their team built quite a few things. And just a few useful links if you want to learn how to write a Node.js module, or there is a Slack channel, a global Slack channel for people interested in neurotechnology that's called NeurotechX. And they have a list of awesome resources about learning more about the brain and how you can track brainwaves. So that was pretty much it. I just wanted to show that these things don't have to be hard to get started with. And yeah, that's it. OK, thank you very much.